Welcome guys, welcome to our YouTube channel Biotech Beats. So today we are going to discuss some few questions of CSIR Life Science Exam Part A, General Aptitude section. So let's begin. Our first question that was asked in CSIR June 2019 was that 12 balls, 3 each of the colors red, green, blue and yellow are put in a box and mixed. If 3 balls are picked at random without replacement, the probability that all 3 balls are of the same color is. Okay, so I hope you understood the question. Alright, so let us assume that we are first determining that the probability that all 3 balls that were picked to be red. Okay, so here you can see that the probability that the first ball should be red will be 3 by 12. Since there are 3 balls in the box that are red and the total number of balls are 12. So the probability that the first ball to be red is 3 by 12. Similarly, now there will be only 2 red balls remaining in the box and total number of balls remaining in the box will be 11. So the probability to find that the second ball to be red is 2 by 11. Similarly, the probability for the third ball to be red is 1 by 10. When you will multiply these 3 fractions, you will get the probability of all the 3 balls to be red. That will come 1 by 220. Similarly, same is the case with the green, blue and yellow balls. Okay, so since they were also 3 in number, so the probability that all balls to be green, blue or yellow will be 1 by 220. Now when you will add these 4 fractions, why 4 fractions? Because 4 type of balls. When you will add these 4 fractions, you will get the total probability to be 1 by 55. Hence the correct option is option 4. Next question. This was also asked in CSIR June 2019. An open rectangular box is made excluding the 4 identical corners of a piece of a paper as shown in the diagram and folding it along the dotted lines. The capacity of the box in the centimeter cube is, means you need to find the volume of the cuboid that will be formed by folding the shaded side. Okay, means this shaded portion will be cut and you need to fold this unshaded portion to make this a cuboid, and you need to find the capacity or volume of that cuboid. So to find the volume of cuboid, you should be having 3 parameters, that is the length, breadth and height. Okay, so what would be the length of the cuboid that will be made by folding this unshaded portion? See, the length will be 20. Why 20? Because this total is 40. This total is 40 and you are deducting 10 from each side. Okay, when you will deduct 10 from each side, then you will be having this length equals to 20. Similarly, breadth will also come 20 and the height of the cuboid will be 10. Okay, now you can imagine guys, when you will fold this unshaded portion to form a cuboid, it will be having length 20, breadth 20 and height 10. So as we know, the volume of the cuboid is L into B into H. So the volume will come around 4000 centimeter cube or cubic centimeter. So the correct option is option 3. Our next question is, the distribution of the grades secured by the students in a class is given in the table below. Okay, so you need to find what is the least possible population of the class. Alright, so to determine the least possible population of the class, we will take out the least fraction. Our least fraction value is 0.1. Okay, and when we will multiply this least fraction value with these with the population that are given in the option, you can determine which will be feasible and which will not be feasible. How? Let us check here. Okay, since the least fraction value is 0.1, when you will multiply the number of students receiving the A grade will be the product of this fraction into the total population. The total population, if assume that total population is 2. So the number of students receiving A grade will be 0.1 into 2 and it will give you the value 0.2. Means the number of students receiving Grade A is 0.2. Can it be possible? I am asking, can it be possible or not? No, it is not possible. Why? Because the number of students cannot be in decimal or fraction. It should be in whole number. Okay. Now let us check with the option B, that is 4. Similarly, when we will multiply 0.1 with 4, it will give you the value 0.4. This is also not possible. When you will multiply 0.1 with 8, it will also give you value in decimal. This is also not possible. But when you will multiply 0.1 with 10, it will give you a whole number 1. So the least possible population of the class out of these 4 options is option D, that is 10. Next question. Our next question is, how many quadrilateral does the following figure have? Okay, so you need to find that how many quadrilaterals are possible in this figure. Okay, so before doing that, first let us define quadrilateral. Quadrilateral is a 2D figure having 4 sides. Okay, so to determine this quadrilateral, we will make the combination of these individual squares and their means we will consider the individual square and their combinations also. Okay, I have also solved this type of question in my previous video. You can check here in the I button over here. Okay, so let us assume that how many quadrilaterals will be there. So we will start from the smallest portion. Okay, means individually all these small squares are also quadrilateral and their combination in 2 like this. These are also quadrilateral because it is also having 4 sides. Okay, and we can consider their combination in 3. This is also quadrilateral. Okay, and their combination in 4 like this. Okay, this is also a quadrilateral. So similarly, to make this question simple, I just alphabetically ordered this small square like this. Okay, now let's consider how many quadrilaterals are possible individually, means with individual square like this, means A, B, C and D, means individually how many quadrilaterals are possible. So you will find that there are 7 quadrilaterals having the only one square. Okay, so it will come like this. The number of quadrilaterals having one square will be 7. How? You can count with me like A, B, C, D, E, F, G. So there are 7 quadrilaterals having only one square. Now to determine the number of quadrilaterals having 2 square, we need to combine these squares in 2 like AB, AC. Okay, so how many quadrilaterals will be there? Count with me. 1 AB, then 2 AC, then CD 3, then this 4. Alright, this 5, this 6, this 7, this 8. Alright, so the number of quadrilaterals having 2 squares will be 8. Now the number of quadrilaterals having 3 squares will be, only 2 possibilities are there, that is CDF and BDE. So it is 2. Now the number of quadrilaterals having 4 square, as I mentioned, it is also having only 2 types of possibility like ABCD. I am making a circle here. Okay, and DEFG. So it is also 2. Now when you will add these numbers, you will get the value as 19. So our correct option is option C. Next question. Of 4 agents alpha, beta, gamma and delta, 3 have to be sent together on a mission. If alpha and beta cannot go together, beta and gamma cannot go together, and gamma and delta cannot go together, then which of the following holds good? Okay, it is, I think, missing here, sorry guys, but it is like gamma and delta cannot go together. So which of the following holds good, you need to find. Okay, so I am just making a diagram here. This blue line means alpha and beta cannot go together, beta and gamma cannot go together, and gamma and delta cannot go together as per our question requirement. So which statement is true? Our first statement is any 3 agents can be sent. So any 3 you cannot send. Okay, this statement is wrong, because whenever you will try to send 3 person, out of those 3 person, 2 cannot go together. You can determine, means if you check this diagram, you will find that the first statement is wrong. Now the second statement is alpha, delta and anyone out of beta, gamma can be sent. So if you send this alpha and delta together, it is possible situation, but who will be the third person? Third person can be anyone out of beta and gamma. No, it cannot be possible, because if alpha and delta are together and you are sending beta with them, then alpha and beta cannot go together. And if you are sending gamma with them, then also gamma and delta cannot go together. So second statement is false. Similarly, third statement is also false. Okay, so the only possible statement is that mission is impossible, because you cannot send 3%. Okay, because whenever you will try to send 3%, 2 out of those 3 cannot go together. Alright, so if you like this video, please like this video and share this video, subscribe our channel and hit the bell icon to get the latest updates. Alright.